Good afternoon, everyone. I am Anna.
And I am Souhaila, and we will be presenting to you our paper, which is written under the supervision of our professor, Cesare Pautasso, from the Software Institute in Lugano, Switzerland.
I'm going to talk about the design.
And I'm going to talk about the evaluation of the BPMN Sketch Miner,
a tool that allows you to go from text to visual BPMN models. Today in classrooms, usually absolute beginners in BPMN are initially presented the semantics and syntax of the language, and then they are given the opportunity to use a graphic tool. The challenge here is that the students need to memorize the numerous different constructs of the language, and we have also noticed that they often struggle with abstracting from process instance level to process model level. In companies as well, such graphical tools are used by business analysts after the interview, but also during the interviews with the stakeholders, when the business analysts are basically listening to stakeholders' needs, taking notes, and trying to figure out the underlying process. The challenge, if the model is prepared after the meeting, is that the feedback cycle gets longer, while the challenge, if the model is prepared during the meeting, is the increase in the cognitive load of the business analyst, who needs to basically figure out the correct control flow of the model, but also the optimal layout of the graph as the discussion is progressing. So to address some of these challenges, at the BPM forum last year, we have proposed to combine textual modeling with mining. And now we have extended and evaluated that work. So the goal is to avoid the need of memorizing the different shapes, especially for absolute beginners. Then to also keep the textual DSL as close to natural language as possible, as compared to other textual DSLs such as PlantUML, which are using more programming language type of DSL. Then to speed up the model generation with the ultimate goal of speeding up the feedback cycle during interviews, and last but not least, as we are using a standard process modeling language, to have the compatibility with standard BPMN editors. Now, having such goals, of course, resulted with constraints in the design of the tool to support the new approach. So in order to avoid the need to memorize shapes, we have decided to use textual modeling by using a constrained language, which is similar to structured notes taking, with a very limited number of keywords to use. Then, in order to speed up the model generation, we have decided to use a web-based tool so that we can offer a live modeling environment where the model is being generated as the user is typing the textual DSL. And we offer export in the standard BPMN XML format, in addition to SVG and PNG formats. Basically, the possibility to have a limited number of keywords and also to have a faster generation of the model is given by our decision to use a mining algorithm in the background, which automatically creates the model and the layout of the graph. Of course, this comes with challenges because we need to decide the right trade-off between expressiveness and learnability, and also the right balance between mining and explicit modeling. We support most of the basic constructs in the BPMN language, and the goal of one of the goals of the evaluation was basically to see which of the missing constructs, such as subprocesses, boundary events, some types of gateways, and some types of events, are considered important by the business analysts. When it comes to the balance between modeling and mining, Basically, of course, we had to ask the user to explicitly model the first-class citizens constructs that are the tasks and lanes. But then we tried to have the rest of the basic constructs derived by the mining algorithm, such as the exclusive gateways, the sequence flow, message flow, and etc. Now we have decided intentionally not to use the mining algorithm for parallel tasks, in order to avoid the effort of stating different sequences of parallel tasks. So instead, we ask the user to state all the parallel tasks in the same line, separated by a pipeline. So basically, the only keywords that are used in the language are the ones for specifying the task types and the event types. Now, I don't want to bother you with the formal grammar of the language. Instead, I'm going to show you a very simplified process so that you can see what's the design of the DSL like. So basically, if you want to state a process where you need to specify the demand, then check if goods are on stock, and then use the goods, you can state the sequence by simply stating the name of each task in a new line. But it's not always that goods are on stock, so it can also happen that you need to create a purchase requisition form and approve it. And this is a different case in the process, and this can be stated as a separate sequence by leaving an empty line between the two process instances. So it's going to be the mining algorithm which is going to determine the existence of an exclusive gateway. So the user doesn't need to explicitly state it unless he wants to, because he wants to label the gateway and then state the conditions. In that case, after stating the label of the gateway, a question mark needs to be added, and then each condition needs to be stated in a new line. Of course, in a process, it's also very important to state who is doing what, and for that purpose, the user needs to state the name of the role followed by 2 dots, and then all of the tasks that come after that role will be assigned to that role until a new role declaration is done. Now, when we have some instances where multiple tasks are repeated, it can become cumbersome to repeat these common tasks. So the language does support the use of the 3 dots symbol, which is basically a placeholder for any sequence of tasks that has already been stated earlier. So in this case, in this way, we basically avoid having to state the first 2 common tasks. If we want to refine the model, we can state the task types by using keywords which are related to the tasks themselves, such as user, script, manual, and etc. And you can notice that here the non-start event doesn't need to be explicitly stated, but if we do want to state a specific type of start event, we need to include the name of the start event in parentheses, and then use the keyword such as timer to state the type of the event. What happens in the behind the scenes is basically this textual DSL is parsed and traces are generated, which are then fed into the process mining algorithm, which creates the control flow of the graph, so the nodes and the edges. Then the annotations are used in order to determine whether some of those nodes need to be tasks or events, and in order to place the nodes in the corresponding swim lane depending on the role annotation. Then a layout algorithm is used to create the layout of the graph and to add metadata so that standard BPMN XML can be used. So now I'm going to leave the floor to Souhaila, who will talk about the evaluation of the tool.
From my side, I will present the evaluation part that intended to answer 2 main research questions. The first one is about the non-experts. whether the tool is able to support them in order to create accurate BPMN models. And the second one is mainly related to the usability. So in our evaluation, we have 30 participants. 21 of them are students. They are students from our university. They are doing their master, and one of the courses they're taking was the BPMN course. So they have just some abstract knowledge about business processes, and they don't know anything about the BPMN notation. The second type of users are the experts. They were of a number of 9. So for the students, they participated as follows. At the beginning, we gave them a training of 45 minutes where they knew about how to use the BPMN Sketch Miner, also how to find the documentation that they may need. And also after that, we asked them to perform their modeling exercise where they had to model a process that we corrected after they have provided us their solutions for getting the accuracy of their models, and also for assessing the different modeling strategies that they followed in order to solve the exercise. After that, we also analyzed the textual models that they have produced in order to get an idea about the usage of the constructs. And also after that, we asked each student who finished the exercise to answer to a set of surveys in order to give us a set of information regarding to their remote understanding, the efficiency and the learnability of the tool. And also they gave us their opinion about the DSL and the editor. We asked them to vote also for some new features that they would like to see in new versions of the tool. And also they were involved in the usability study. So this was the process that we asked the students to model. This is composed of 5 process instances with 3 swim lanes, and they are required to use, in that case, different constructs. Here we plot the accuracy of the models of the students, of the solutions that they produced. We can realize here that the students have been using different modeling strategies, like 8 ones, and only 38% of them were the students who followed the same order of processes as they were stated in the text of the exercise. And the students managed to finish the exercise in 1 hour and a half, and the average correctness of their models was of 87%. We also tracked the use of the examples and tutorials available in the website of the BPMN Sketch Miner. So we can see these black points here, which is representing the use of the tutorials and examples pages by the students. So we realized that the students were really using these resources during the evaluation period. And as a result, we had like 48% of the students who used some construct that weren't shown to them during the training, which means that they could understand them by themselves just by looking at the documentation. Regarding the experts, they tried our tool. We analyzed also the DSL usage, the constructs usage of them, of their inputs, and also they responded to the survey in order to provide us the same information as for the students. For assessing the usability of the tool, we followed a method called the system usability scaling, which allowed us to calculate a specific score that reflects the usability of the tool. It consists on a survey composed of 10 questions, 5 negative ones and 5 positive ones. And after calculating the score, we got an amount which is equal to 69, which is considered, according to that method, a good score. We also used some questions of this survey for assessing the learnability and the efficiency of the tool. So, for example, we got here some analysts or some students who disagree with the fact that the BPMN Sketch Miner is a tool which is easy to learn, but they were just 2, and one, for example, who thinks that he would need some technical support in order to use the tool. We dedicated actually a special survey for the efficiency and learnability, where we asked students some specific questions and also analysts some specific questions about, for example, whether they find themselves able to type faster than visually modeling, where, for example, the analysts, majority of them agree with that they can type faster. And we can see here that almost all of the analysts agree with the fact that they can learn the BPMN Sketch Miner very easy. As same for the students, where, for example, all of them, they agree with the fact that the visual output was very helpful for them in order to understand the flow of the process. We had also a user satisfaction study where we had a dedicated survey for that and had some set of questions. Like, for example, we asked the respondents of the survey how much they would likely rate the BPMN Sketch Miner. And for example, we asked them whether they may suggest BPMN Sketch Miner as a modeling tool for some friend or a colleague. And we got a percentage of satisfaction of 57% out of 30 respondents, and even some of the respondents were highly satisfied, and they were like 13% of the total amount. We are also gathering information and feedbacks in our website, where we got a set of feedbacks which we appreciate, and they are very helpful for us in order to know whether the BPMN Sketch Miner is reaching the goal for which it was conceived. As a conclusion, as we said before, the BPMN Sketch Miner, it is a tool which is combining the explicit modeling with mining, which means that the user only need to input a minimal input based in a DSL, which is made to be as close as possible to the natural language. And also we had evaluation, which was for responding to 2 questions. The first one is about whether the BPMN Sketch Miner is helpful for beginners to produce accurate models. For example, we had the experiment with the students who had to model a process where the average correctness of the whole solutions was of 87%, and they managed to do the exercise in less than 1 hour and a half. And for the second question was about the usability, where we used the SUS method for calculating the scores, where the score for the students was of 64 and the score for the analyst was of 76. So in another thing is that we found that 62% of the students had an idea about the tool, that they find it very promising, and even 19% find it a very powerful tool. And regarding the experts, majority of them find that the BPMN Sketch Miner is supporting actually the majority of the crucial constructs. So as future work, we had also gathered some opinions from the respondents of the surveys about the concepts and the features that they would like to see in the new versions of the BPMN Sketch Miner, and that's what we will take into consideration in our future work. So if you want to use our BPMN Sketch Miner, you just go and check the website, or if you want more details about the design or the evaluation, you can go and read our paper, or also if you have any further question after trying the tool, you can contact us, and we'll be happy to answer to any of your questions.